Alright, so here's part 2, getting ready for the quiz. This is solving exponential functions and log functions, being able to use the concept of properties in order to actually solve for x. Alright, the very first thing I should see on this type of problem is I have a couple log 3's here, and I know that since there's a plus sign in between, that this plus sign had to come from the fact that these were being multiplied together. So let's go ahead and do that. So I had log base 3, and 8 times negative 5 means it had to, when it condensed down, that had to be from negative 40x, and that was equal to 1. Well, now if you take the natural log, so if I take the natural log of this side, of the left side, and the natural log of the right side, that means that it had to be, remember b, so remember it's b to the y equals x, so therefore 3 to the first, has to equal negative 40x when you do this, because that's one of the properties. Well, so therefore I know that 3 equals negative 40x, and so I can solve for x, just divide both sides by negative 40, and therefore x is equal to negative 3 over 40, and that would be my answer for x. Alright, so for question 3 here, the first thing I want you to be able to see is that there's a number out front of the problem. So I have this number out front of the log equation. Well, I can get rid of that if I divide, and all of these are all together. So there's no plus or minus. That means all of these are being multiplied, right? So I can divide this side by 4 and this side by 4. And so that's going to give me this log function. So now I have log 8 of x minus 5 equals 4. And for all log functions, we know that it's the same as kind of the inverse of the exponential. So I can write that as if it's 8 to the 4 equals x minus 5, which 8 to the 4th power would be 4,096 equals x minus 5. Add 5 more, and I get x equals 4101. And there's our answer for 3. All right, similar type problem here on 4, except I have this 5 that's not really tied to this log function. So the very first thing I can do is subtract 5 from both sides. And now I have a log base 6 of x plus 2 equals 1. And now I have a log function. So this just means 6 to the first power equals x plus 2. And therefore I get 6 equals x plus 2. And x would simply equal 4. For number 5, I can think about this. I have a log 17 here and a log 17 on the other side of the equation. So if I divided these out, right, that means the only way that these two would be equal is if these two expressions were equal. So therefore I can say then 8 plus 3x squared has to equal 4x squared minus 2x. So now I can just set those equal and move things around and solve. So if I move this over, I get x squared, and I have the minus 2x, and move the 8 over, minus 8 equals 0. Now I can see I have a quadratic equation. I can simply factor. So this would be 8 minus 4 and x plus 2. And therefore x has got to equal either 4 or x is equal to negative 2. Now this one I do want you to check for extraneous solutions, but we'll worry about those at a later date. So those would be my two answers. Once again, I would need to check for extraneous solutions and see if these actually work, but I'm not really worried about that for the quiz right now. Alright, slightly harder, but not too much. Here on 8, I can see that I have an exponential function. This negative 5 is not tied into the exponential function. So let's go ahead and add this 5 across. So I have 7 to the x plus 5 equals to 49. Now, exponential functions, I have to use the natural log in order to get rid of them. So I'm going to use the natural log of both sides. And I know that means that's the power rule. So therefore, the x plus 5 has to come out front, and that's going to be multiplied by natural log of 7 equals a natural log of 49. And now I can simply look and say, right, well, I can divide out this side, natural log of 7, divide out this side, natural log of 7, and therefore I got x plus 5 equals, all right, so when you divide out natural log of 49 and natural log of 7, that just gives you a value of 2. So that means x has got to equal, when you move the 5 over, so subtracting 5 makes it -3. And there's my answer for that one. All right, so for this first problem, this next problem, I still want to look and see what are my exponential functions. Well, my exponential function is this 8 to the p plus 10. So the 5 not really playing a part of the exponential function. So the very first thing I want to do is divide both sides by 5. And that's going to leave me with 8p plus 8 to the p plus 10 equals, that's going to equal the 3.6. Now in order to get rid of this exponential function, I need to do the natural log of both sides. So when I do that, that's going to bring the p plus 10 out front. So I'm going to have p plus 10 times the natural log of 8 equals the natural log of 3.6. And so now I can simply just divide out the natural log of 8 from both sides. So I'm going to divide out the natural log of 8 from both sides and leave me with p plus 10. Then it equals 0.616. And so now when I subtract 10, so I get p equals -9.38.